Python has many powers centered around lists. I recently used two of them, list comprehension and sorting. I want to share a story about these powerful compact statements. The story starts with a problem I wanted to solve. How to keep a sorted list of version numbers for an unruly software dependency needed by multiple software applications. This software dependency had many versions, and worse, did not follow a consistent rule for the version number format between versions. Some versions had a major, minor, and revision number. Others had just a major and minor number, and finally some just a major number. Worse, some versions used the same subset of the same major, minor, and revision numbers, such as 1, 1.0, and 1.0.0, a truly obnoxious setup. Sorting had to follow these rules. Versions are sorted in ascending order by major, minor, and revision numbers. When there is a subset of the same version, a major-only version comes before a major-minor version, which comes before a major-minor revision. So for example, version 1 is before 1.0, which is before 1.0.0. So to produce a sorted list, I broke the processing into 3 steps. The first step transformed all of the version numbers into a consistent format that could be mathematically compared. To do this, I converted the version number string to a triple of numbers and replaced any missing minor or revision numbers with -1. As a side note, the spacing in these examples is not important. The second step sorts the number array to determine where the version numbers are moved in the list. So for example, the last entry in step 1, 2, 12, is moved 3 entries up in the sorted list in step 2. By using a -1 in step 1, I made sure that 1.0, 1.0.-1, came before 1.0.0, and 1.-1.-1, came before both of those. Most importantly, I kept track where the version numbers changed position in the list. In the third step, I used the positions in the sorted number array to shuffle the positions in the original list of version strings to produce a final sorted list of version strings. Python's powerful list comprehension statements allowed me to do this with a few lines of code. List comprehension statements, which are highlighted in yellow, let you create lists algorithmically. A list comprehension statement is divided into 2 parts, the context and the expression. The context generates the elements for your list, and the expression transforms them into a final value which ends up in your list. We see the solution's list comprehension statements broken into the 2 parts. The first list comprehension statement takes a string list of version numbers and passes each version to a function to convert that version number into an array of 3 numbers, the major, minor, and revision number. Each conversion of a version string happens in 3 parts, which is illustrated with the example of the version string 1.0 being processed. First, the string is converted to a list of string numbers by splitting it along the dots. Next, if there are any missing major, minor, or revision numbers, they are replaced by a -1. Also, in this step, the string numbers are converted to actual numbers. Finally, the array of numbers is returned into the variable ver_list. Once this list of the array of numbers is created, we then build a list of indexes called sorted_list_index, which will let us track how the version numbers are shuffled around to produce a sorted list. What shows off Python's flexibility is that the keys for the sort of the variable sorted_list_index come from another variable var_list, which contains the number array list of major, minor, and revision numbers that we created in the previous slide. Once sorted, we see that the list, sorted_list_index, elements match up with the sorted list of version numbers. Now that we know the correct sequence that the list of version strings should be arranged, we can use a final list comprehension to shuffle the version string list elements to have a sorted list. Python's list provides us with a compact and powerful way to complete many data manipulation tasks using list comprehension and sorting. Where can you apply these tools to solve your problems?